friends, and welcome to YouTube channel Freedom Tech. And in this session what we are going to learn? In this session we are going to see how to control our Arduino IDE Wi-Fi card with the help of CSRT tracker. But before we move to our practical, friends, if you learn something from our videos, please consider to subscribe our channel. Okay friends, thank you so much, and let's get started. So friends, in last session we have successfully controlled our Arduino IDE Wi-Fi card with the help of CV zone hand tracking module. And in today's session, we are going to control our Arduino IDE Wi-Fi card with the help of opencv CSRT tracker. Okay, so if you don't know how to control the Arduino IDE Wi-Fi card with the help of CV zone hand tracking module, I will mention the video link. Watch video and control your Arduino IDE Wi-Fi card with the help of CV zone hand tracking module. Okay, so in today's session we are going to use here a latest Raspbian OS, which is the Raspbian OS Bullseye 64-bit version. For this tutorial you need to install first opencv and TensorFlow Lite on the Bullseye. I already created a video how to install TensorFlow Lite and opencv on Bullseye. I will mention the video link. Watch video and install all these basic modules. Okay, then for enabling the CSRT tracker on the Bullseye, first we need to install sudo pip3 install. Means after completing the installing opencv and the TensorFlow Lite, we need to install opencv-config python package. So sudo pip3 install opencv-config python and just hit enter. It will install opencv-config python package on our Bullseye 64-bit version. Okay, as you can see, requirement is already satisfied because I already installed the opencv-config python package. That's it. Now we are ready, and I have created here a repository. The repository name is virtually-rb control. The V is basically capital. Okay, I will mention the link of the repository. Open the link from the browser and just copy the link, then sudo git clone, and we need to paste our link inside the terminal and just hit enter. It will clone our repository. Now first we need to change the owner for our repository. So sudo chown space -R, pi is the user, and pi is the group, and V is capital. Our repository name, which is the virtually-rb control. Just hit enter. That's it. We have successfully changed the owner. Now first we need here rpi app. If I go in menu accessories, rpi apps, and then we need here Arduino IDE for configuring ESP8266. Okay, so in previous video I have already explained all these things, how to install Pi apps, how to configure Arduino IDE. Same steps you need to follow for installing the Pi apps and the Arduino IDE software on Raspbian OS Bullseye. Okay, so I am not going to explain all these steps again because I have already explained all these steps in previous video. Okay, so watch video and install same way the Pi apps and Arduino IDE on Raspbian OS Bullseye 64-bit version. Okay, so inside the virtually-rb control repository, as you can see, this is what our folder. Inside the folder we have here a text file. Okay, and this is what our text file, and as you can see, this is the link for Pi apps. Okay, you need to simply copy and paste this link inside the terminal, and this is what our ESP8266 board link, which we want to copy and paste inside our Arduino IDE additional board link where we want to paste this link. Okay, so same steps as I already explained in previous video, same steps. Okay, and for Arduino IDE the code is also same. As you can see, mgtt moto.ino. Let me open the code, and now it's opening our code with Arduino IDE software. Okay, so friends, as you can see, this is what our code. Okay, IN1, IN2, IN3, IN4, what our L2, 9, 8, and DC motor driver board. This is what our ESP8266 pin. Here you need to mention your router SSID, then router password. Then this is what our online MQTT broker server. Same steps, same code for Arduino IDE. So For that, I have already explained all these things in our previous video, so I am not going to explain all these things again in today's session. We are going to move on the tracker side. Okay, so simply I am going to close all these things, and I have already installed the code inside our ESP8266. Okay, so we are going to start with our tracker, the opencv CSRT tracker. Okay, so let me open here Sony Python IDE, and then we are going to open our repository py, and we have our repository virtually RB control and tracker b.py. This is the basic tracker file. Okay, so first we are going to open tracker b.py. Okay, and I am going to explain here how we can use the CSRT tracker. Okay, so import cv2, then import pow mqtt.client as mqtt. This is for basically sending the message with the help of our MQTT broker. Okay, so power MQTT client as MQTT, then numpy as np, then from time import sleep. Okay, then cap is equal to cv2.video capture. This is what our normal code. Okay, then simply here, as you can see, trdict, this is the variable. Then as I mentioned here, we are going to use the CSRT tracker. So mention the name of the tracker CSRT, then cv2 dot t is capital tracker CSRT all the way capital, then create. Okay, tracker CSRT, then underscore create. Okay, then tracker is just a variable. Tracker is equal to tracker, and tracker basically trd, this trd, then we need to mention here our CSRT tracker. Okay, then read frame is equal to cap.read. Then we need to first mention here our region of interest area for tracking, for enabling what we want to track here. Means we want to mention here our object for our tracker. So for mentioning the object, or we can say for tracking the object, we need to mention here our region of interest area. So we are going to use here our ROI method. So for that, first we need here our frame. So frame is just a variable. Frame is equal to cv2.resize frame. This is what our frame size, which is the 640 width and 480 is our height. Okay, that's it. Then bb is just a variable. Basically, this is what for a bounding box. So bb is equal to cv2.select ROI. This is how we select ROI. Okay, this is the method basically for selecting the region of interest area. cv2.select ROI. ROI is basically capital. Then inside that we need to mention our frame, and then we are going to initialize our tracker. So tracker, this tracker, we mention here a tracker. This tracker is basically now our CSRT tracker. So tracker.initialize means init, and inside that we are going to use here our frame. Then we are going to use our bounding box, means our select ROI method. So if I start the code, as you can see, this is what our first frame. Okay, this is basically not live frame. This is the first frame in freeze movement. Okay, and this is our object which we are going to track here, our Arduino IDE robot Wi-Fi card. So we need to select our region of interest area. Means in this, what is our region of interest area? Our region of interest area is basically our car. So we need to create here, simply select the region of interest area. We need to click on our mouse like this, click on it and select your region of interest area. That's it. So this is what our region of interest area, ROI. After selecting your ROI, you need to simply press enter. Then it will go with the while loop. Okay, this is the first step for initializing the tracker. You need to select your region of interest area. Means you need, in simple language, you need to select your object which you want to track. That's it. So friends, we have successfully initialized our object. Now we want to update our tracker because we have our object. So this is the function def track. Inside that we need to pass our img. Then success box is equal to tracker.update. We need to update our tracker, and inside that we need to pass our img. Then if we have success, then we will get the x, y, w, h coordinates with int for a in box. Okay, then we have now x, y, w, h coordinates, so of course we can draw the rectangle. So this is what our simple method for drawing the rectangle. CV2 dot rectangle, img x, y, x plus w and y plus h, and this is the color and this is the thickness. Okay, as we always do. Then we want here a centroid points. So this is the method for getting the central points. Okay, so cx and cy, this is the method x plus w, okay, then divided by 2, then divided by 2 again, y plus h. We will get cx and cy. This is the basic method. Okay, then of course we have now cx and cy points, so we can draw a circle on our object, means our center points. Okay, CV2 dot circle img cx and cy, okay, then color, and we need to fill the point, we need to fill the central point, so we need to mention a -1. Okay, that's it. So this is the basic method for updating our tracker. Okay, so after that, while loop, as we always do. Okay, then frame is going to CV2 dot resize. Then here we are going to skip some frames. We are going to skip 10 frames. Okay, and then here I have call our function track, and inside that we need to pass our frame. Then CV2 dot inshow. This is the same method. Then cap dot release and CV2 dot destroy all windows. So this is the method. This is the basic method for initializing the tracker and the updating tracker. Okay. Says select ROI, means select the region of interest area. So in this case, as I already explained, this is what our ROI. Now you need to simply hit enter. That's it. As you can see, now it's the CSRT tracker is basically tracking our object, and as you can see, this is what our center points, the red colored circle. This is what our object center points, which we are going to use for controlling our object. Okay, so let me show you here. As you can see, our tracker is basically tracking our object. Again, as you can see, it's basically tracking our object. So this is how our CSRT tracker is working. Okay, this is the basic code. That's it. Now I hope you all clear. First, we need to select our region of interest area. So ROI is our car. Now this is what our live frame. Okay. So what we are going to do basically, we are going to draw here line here and here, and then we can see our car is move in between these two lines. A forward and the backward. Okay. So we need here a line. So we are going to use here, as you can see, we have here x and y coordinates. So if I move the mouse on our frame, you can see the xy coordinates is basically changing. We need here a line from here for this point. If I move the mouse over here, in x and y, as you can see, the points is 80 is basically x and y is 151. So this is the start point, the 80 and 151. So here we are going to mention the start point 80 and 151. That's it. Then the second point, let's say here. Okay. So what is the x and y coordinates? 485 and 232. Here, as you can see, here it will show here. Okay. So if I move mouse over here, 485 and 228. So the end point of our first line is 485 and again 225. Okay, 485 and 225. Okay, so this is what our first line. Now second line. Okay, so again let me open the frame, and the second line is here. Let's say here x is 1 and y is 334. So 1 and 334. Okay. Then for second line, second point, let's say here, over here. So X is 302 and Y is 478. 302 and 478. So 302 and 478. Okay. So now we have our points for drawing the line virtually. So let me save first the code. And so friends, we have entered our coordinates inside start point, end point for drawing the lines on frame. Now simply if I scroll down here, scroll down, and here we need to enable our cv2.line method. So just remove the hash, okay, just uncomment the hash, and we have now our cv2.line method, and inside that we need to mention start point, end point, color, thickness, start point 1, end point 1, color and thickness. The color and thickness which we have already mentioned over here. As you can see, the color and the thickness, and start point, end point, start point 1 and end point 1. Then we have our lines on our frame. Okay. First we want to select our object, the region of interest area, just hit enter. And as you can see, now we have our lines. This is what our lines which we are going to use for controlling our robot Wi-Fi car. Okay. So now we need here our action. Okay. So what is the action? Action is basically forward and the backward. So friends, simply we can say here, if the CX means the center point is in between this point and this one. Okay. So this one is 484 and this one is 79. Okay. So 79 and 484. So we can create here a condition if CX in between 80 and 484, okay, the action will be back, means the back function, and else the forward function. The back function will be send the back message and forward function will be send the forward message. Okay. As you can see, the action is backward, forward, backward, forward, backward, again it will come forward. Okay, if you press the escape, it will stop our code and it will send the stop message on our subscriber side, and the action will be stopped, means our robot car will be stopped. Okay, so this is how we can control our robot Arduino IDE Wi-Fi car with the help of CSRT tracker. I hope you will learn something from this video. We'll meet our next video. Till then, thank you, take care, and bye bye.